I welcome you all. I am Dr. Bukhari. In the series of lecture of data science, it is the first lecture on introduction of hypothesis testing. In this introduction, we will go upon the what is hypothesis and how we will test. Its execution by using different software will become in the coming lectures. Hypothesis testing is a formal procedure to investigate over ideas about the world using the statistics. It will start from that what if, and then what will happen. If this happens, then what can be the other options, and then if it is actual observation, then either it satisfies with the statistical results of populations or some standards that you have, all these things. Now these questions be answered by the hypothesis test. Now remember that when you want to test the hypothesis, for this testing, like a blood test, we will have here some sample, like you get some blood as a sample. Here you get some sample from population. Since it is impossible that you touch all the population or get all the data by freezing it or by just compiling it, what we will do, we take few samples, and then from these samples we apply by some hypothesis, and then we define these hypotheses, and on the basis of that sample we get some conclusion. Now definitely to get some inference, some statistics methods are involved, some transformation are involved, some probability distributions are involved. For example, we consider some easy example. We want to find out what will be the happen if we use fertilizers of different company. So it will start from observation. It will be, and then coming to the question that either this fertile is a good, or for that the height of plant will be increased more, or like that. We will have a different fertilizers, and then we have a different results, and we will compare it with the some standards that we have a population, and we will get a conclusion. Now we can see that these all are hypothesis testing procedures, but starting from observations, and on the basis of that we will get some data, and then we hypothesize it, and we will get the results, and we will find out conclusion that the fertilizer A is better or B is better, like that. It was that plan. Now you remember that in hypothesis testing we will have two options. One is the null hypothesis, another is the alternate hypothesis. We can see from the figure, for example, if you apply fertilizers and nothing will happen, no effect on the fertilizers, or you can say it is almost zero effect, we call it null hypothesis. Mean we hypothesize it that it's zero, improvement is zero, its effect is zero. And the other hand, we will say that if its effect is not zero, it is definitely, you can see from the figure that the height has little bit increased as compared to zero. Now it is an alternate hypothesis. Now remember, no, it cannot be possible that both hypotheses will be true and both will be false. Now one will be false, then definitely other will be true. Now in mathematically words, we define the null hypothesis representing by H naught, and it is a value that we have obtained from the population, which is equivalent to some overclaim. For example, we here claim that the height of plant is 10 centimeter. Now it is the null hypothesis that is a 10 centimeter. Now alternate hypothesis will representing by H1 or HA, or you can say that H by small a. Now this statement will say that its value is vary. Now remember that when we say, for example, the plant height is 10 centimeter, the alternate will be, it may be more than 10 centimeter. You can see from the figure as well. It may be less than 10 centimeter, or it may be equal to 10 centimeter. Means in alternate hypothesis, we have three options. Now we will write it in the form of mathematically as well in the coming slides. A very good example to understand the hypothesis testing. For example, we bring a defendant who is charged for some crime. Now This defendant is actually our data in practical field, and now judge will be decide the case with the help of prosecutor and defender. Now judge is the statistical distributions that we will come in a coming slide we will study. Now judge have a book which will tell us by the statistical distribution that either this defendant's relation is strong or weak. Now in the start of the case, it will start from the defender, that is a null hypothesis. It will say that he is not guilty, and then how we will prove? The judge will definitely ask the prosecutor, and he will bring some witnesses to prove the guilty. In the same pattern, the witnesses of prosecutor and the witnesses of the defender, these all will go through in the probability distribution, either distribution curve, statistical distribution, we will find out that where it will fall, and then we will decide it accordingly. Now remember that the defendant, that is actually data, now it will have some value. The judge will compare this value by the population itself, and then accordingly it will decide about its innocence. Now if he is innocent, then definitely he is not guilty. Now that's why you have seen that we always start from the null hypothesis. Null hypothesis means that the data in the sample has no relation with the data of population. No relation. You have seen that. You have very good relation with your friend, with your family, with your father and brother, sisters. No, this relationship may be about 90% weightage. Now, null hypothesis means that almost it has no relationship. Means for example, you consider the mean of their population is 90, then null hypothesis is almost zero. That is, it has no relationship with the population. Now, it is a relationship of sample mean to the population. Now, the start of the hypothesis will begin by the defending the innocence. Now, if we fail, then definitely alternate hypothesis will apply, and then he will be proved guilty and he will be sent jail. In the same pattern, in the alternate hypothesis, we will find out the value of the test statistics that we will calculate from the data. Now, the value of test statistics, that is actually, you can see as a judge, it will tell you that either he is guilty or not. Now, how you find out the test statistics? It is a question here. And before going that, let's have some more question that when we need hypothesis testing, and then we will solve it further. For example, you consider that we have 100 bolt and they are examined for production. Their mean value is coming 30 millimeter. And now my question is that, can we generalize it? We can say that yes, next 100 bolts or 200 bolts, their mean will be again 30 or 29. No. You can see that there will be maybe possible that next 100 bolts or 200 bolts, their average will be 28. That is less than 30. Or it may be 31. That is greater than 30. Or maybe 30. Means we will have always three options: greater than, equal to, or lesser than. We have to check it out, all these three options. Why? Because it is a sample 30, and then there will be some standards of population, and we have to compare it accordingly. Another question where you can see that voltage of a circuit, it is coming like a fluctuation. You can see from this graph. Now we take us 40 readings. Due to fluctuation, we will see its mean is 1.26, and deviation, that is standard deviation, that show us the spread, it is 0.14. Now we get the hypothesis that the average output is 1.3. Can we conclude? Is it 1.3? Now it is the actual reading 1.26 for just 40 readings. Now from our own self, can we hypothesize that almost, since it is 1.26, its reading will be 1.3. Can we do it or not? Or now with the test level of 0.05. That is accuracy level or error level, you can say. We will study it, that it is 0.05. Remember that when we go for hypothesis testing, you must remember in your mind that definitely we will have some population, and since the whole information from population is not available, generally we will have a mean that is represented by mu and standard deviation of this population, and then we will just take few samples. It may be 1, 2, 3 and 10 samples, 20 samples, and then after taking these samples we will get these statistics from this sample. These statistics are, you can see that it's an average value, that is a mean, and standard deviation, and then we apply these test statistics, that is a probability distribution, and we will get some conclusion, and on the basis of this conclusion we will generalize it about the population, that yes, how the characteristics the population have. Now these are tools through which we have seen that in the criminal judgment, the accused is proved guilty or innocent in the same pattern. Now it is a law that we will apply it. It is the source that we will which will tell us about the hypothesis that either the relationship is strong or not. Now first is mean, that is a summation of all value divided by total n. We will get the average value, that is called mean. Next is standard deviation. Now standard deviation is that how much dispersion is from the mean. What is this? You can see from the formula that x bar is actually average value that we have calculated from here, and then what we are doing, all values are spreading round about the average value, that is the dispersion, and then dividing by total numbers. Now we can see that if it is very small variation, then it is ideal, and if we have a more spread, then definitely it will be not good for us. Now on the basis of this spread, since you have seen that when witnesses bring in the court, they will tell about his guilty or not. Now the judgment is based on their statements, their words. They will say the whole story. Now here the judgment in the data in hypothesis testing is on the basis of deviation, that is a standard deviation. You will see that either it is small or more. On the basis of standard deviation and mean, we will decide about its relationship. Now you can see that here, who is a person decide about the results, about his guiltiness or not, is the judge. Now here the judge is z-score. Now from this z-score we draw a distribution. Now this distribution will tell us that where the value or it is fall, and how we can find out it is a null hypothesis or alternate. Coming slides. Now in z-score, in z distribution, you can see that what is involved. It is involved average value. It involves mean of population. You can see this both are mean actually. One is coming from sample, another is coming from the population, and then this standard deviation of population, and then the total sample. Now these distributions will give us a graph, and this graph will decide that either H0 is correct or we have to take the alternate hypothesis. Now you can see it is a graph of z-score that we have drawn here. Now from the center is a man whose statement is very correct. You can say that who is the ideal person. We can say the mean that the average person will stand here in terms of statement, whose statement is not biased. He will stand here. In data, the average value will sit here because we have all different values. Now these values spread, you can say that it is a standard deviations, mu, 1 mu, 6, 2 mu and 3 mu and so on. Now scatteredness is the data is coming due to the standard deviation. Now we will calculate the standard deviation of each point from the previous formula on the slide, and you can see that in a one standard deviation almost we can get witness almost 68%, and in two standard deviation almost we get 95% witnesses that give us correct statements. In the other words, you can say that. And beyond standard deviation, 2 times standard deviation on both sides, we will have about 2.5 and 2.5, about 5% standard deviation is coming beyond 2 pi standard deviation. Now it is a theme that generally the closer the mean, the people will be having the relationship, the strong relationship. Now if the person is innocent, then definitely he will have a less relationship, and it will lie on this corner side. Now remember that in null or alternate hypothesis, we generally represent by H0 and H1. In H0, you can see these boxes are just samples. From these samples, we will say, for example, your average is coming 30. It's the population average actually, and you say that we will get some sample and its average is coming exact 30. If it is yes, you will say it is H0. And you can say no, the sample average may be lesser than 30 or greater than, then it will be say that it is a alternate hypothesis representing by H1. That again we will study in a coming slide. Very good example. If you understand this single slide, you will understand the whole story. Now this curve that you have seen, that we have got from the Z distribution, that is a judge. Now this Z, in the Z distribution, in the center there are the data. Here we spread based on the value of standard deviations. You will see that if the point is lying on this side, then definitely on the right side, red colors, we will have a less relationship. No, here it means that the people are more innocent. You can see that these two sides are, people are more innocent. Why? Because the central value is a strong relationship. That's why this person, you will see that we have put in a jail, because they are guilty. Since they are close to the central value, that the central value has a more strong relationship. And then corner sides where we will have a lesser relationship. Now according to, you have seen that almost 2 times of standard deviation fall in the 95%. Now generally here in alpha by 2 and alpha by 2, we will say it is total is alpha. We say that the 5%, remember in this distribution, if 5% fell in this, they will provide witness that they are innocent. Then what will happen, that we will say that 90% are witnessing that he is not innocent. Then that's why we go for alternate hypothesis, because less than 5 or 5% is saying that the person is innocent. Then we reject null hypothesis, and then we come to that the person is guilty, because 95% of people are saying that they have some relationship with the population, that is the population average. If the test statistics fell in this region of rejection region, you can see that these red colors, we reject the null hypothesis. And we will say definitely it has some relationship, because just out of 100, just 5% are saying they are innocent, then definitely the person is not innocent. That's why we reject it. Person is not innocent, because 95% on the other hand, 5% means that 95% or 0.95. You can say that if it is 0.5 value, it's 0.5 means 5%. And if test statistics fell in non-rejection region, here we do not reject the null hypothesis. In the whole story, we have seen that from the population we will get different samples, and these samples we will get some statistics. Nowadays in a COVID vaccinations, different people perform statistics, because it is not possible to get the sample of whole people in a city or in a whole country or world to get some results, to get some conclusion. That's why we will get some sample, and this sample will given to some statistics, either different transformation that we will study in a coming slide, and the basis of we will get some result infer about the population parameter. Now definition of hypothesis, we can say in statistical form that it is a statement about the value of population parameter developed for the purpose of testing. Now this statement definitely it is involved null or alternate hypothesis. Now in hypothesis testing, it's complete procedure through which we will go and to evaluate the result about the hypothesis. Now what is the procedure? In a coming slide we will study that. Remember that here the judge was Z distribution. Now test statistics are the judge who draw the distribution curve for which we will get the result. Now in statistics we will use different test transformation. Here we can see that it may be Z probability distributions, it may be T probability distribution, it may be F probability distribution, or chi. Now these are we will study basis of your interest in the coming days, one by one. Now we will not go all these three because we don't want to make mistakes. It is just introductory. There are different conditions that sometimes we apply Z, sometimes we apply T, and sometimes F or chi-square, on the depending upon the situation or variables, standard deviations, skewness, and so on. For all these, we will have a critical value that divide the point where the null hypothesis is rejected and where it is not rejected. Now this critical value we find out depending upon how much the accuracy you demand it, or how much favor you give for the innocency or not. Now basic steps that we will study here to find out hypothesis results. First is state the null hypothesis and alternate hypothesis. Now first we will define that what is H0 and what is H1. Remember that in null hypothesis that is a nothing. We generally apply write that the weak relationship between the population mean, and alternate we write a strong relationship which is like with close relationship with the H1, and then we will write define about the significance alpha. Alpha means very simple that in a criminal case we have studied that there was just 5 people that was witnessing that the people is innocent. That means how much you can favor. Now it is like that. You have to define that how much you can, if the value can be wrong, you will accept it. It is generally in reading or in experiment we write 5%, that you have written that you have seen that it is writing that alpha is 0.05. It means that 95% accuracy we need it. And then sample size. Generally we keep the samplings more than 30, but not very less. Now applying the different test statistics and sample distribution. Now this sample distribution will tell us that what test statistics we apply. Either it is normal distribution, that is a Z distribution, or T, or some other distributions, and accordingly we will apply. Determine the critical value that divides the rejection or non-rejection region. Now here for example, if you write alpha is 0.5, on the basis of that you will have to get some critical value, evaluate it, and find out where is the separation point between the null and alternate hypothesis. And then next we have to find out the test statistic, that is a Z-score you have to find out. After finding the Z-score, next point is coming about the decision. Now remember that if test statistics is inside the rejection region, we will reject the null hypothesis, because otherwise 95% or strong relationship are coming toward the alternate. That's why we reject it. If the test statistics fall into non-rejection region, then definitely we will not reject H0. Now stepwise, if we see that in test statistics we will have a data, we state hypothesis, alternate or null, and then test statistics we will define it. In test statistics we will see the distribution. On the basis of that we will define which we test statistics applied, and then we will have to calculate it, the value of Z or some other distribution, and then we will about the decision we will have see that inside the distribution that where the test statistics fall inside it, according to if we have to reject or not reject, and that will be our conclusion upon it. Now let's have a question so that you will have a more idea practically. And for example, you can see that you have some population and its average is coming 50. It's you can see that, remember that it's a population, not sample. Now if we get some sample mean 20 from some sample, can we conclude that it is almost equivalent to 50? Now it's a question that here your average is mean is coming 20, but the population mean is coming equal to 50. Now can we accept it? We say that yes, it is almost just a difference of 30 and there is no matter. Now this type of question we will apply it. Now in the whole story we have seen that we have three options here. First option is we have three options, that is a H0, H1, and in a two tail we will have either a value is greater or lesser, that is not equal to. In left tail we will see that we will have a value that is a lesser than mu naught. The mouse is coming problem, that's why I'm trying to fix it. Okay, here you can see that in two tail we will have the value that mu is mu naught, no, it is average value is given here, and what we want that test out alternate is that it is not equal to mu naught, that it may be lesser than or greater than. Now in some time we required also that just we want to find one sided left tail, that it is a value of lesser than the mean of the population. In some time we have to check only that the mean is greater than the average. Now in this diagram we can see that in the whole distribution here this part is about the non-rejection region, because there are the witnesses are here, they give some witnesses close relationship with this central value, that is a mean value. Now here the closer the central value, it means the closer relationship means definitely the relationship will be not rejected. And if we have a far value here, we will say that it is a rejected. Now it is coming in the critical region. Now we can see that in value of alpha in the start we have to define it, that how much accuracy you need it, how much you can neglect the people come in the against the, you can say that against the witness, 1%, 5% or 10%, accordingly it will be applied. Now again we can see that in the three tests, that first is you can say that we will have a in two tail test, it is last is two tail test, one is left tail lower tail test, that we say that average is lesser than 3. For example, if population average is 3, we will say that here the sample average is coming lesser than 3. Here we say that population mean is coming greater than 3, and here we are saying that it is not equal to 3, means it is both sides, it may be lesser than 3 or greater than 3. Now these three options are here to find out hypothesis testing. Now about the type of error, we will have a definitely error are possible due to different reasons. It may be that sample you have obtained are biased, or the less quantity, or you may have a typing error due to that. So type 1 error is, you can see that here, if we reject the true null hypothesis, for example, the people say that he is innocent and you reject it, so it is called the error, type 1 error. Now we will have to calculate the error also. We will see that how you will calculate. Very interesting story. Again, you can see that in a real world we can see that if defendant is innocent and here defendant is guilty, there are two options: either defendant is innocent, now defendant is guilty. Now what will happen? He will bring in a court, and court is we have a jury, and they will decide. Definitely, if he is innocent, then he should be said that it is not guilty. He should be lying here in this box. because he is innocent defender. Then we can see that if we say that he is not guilty, it's correct. But if we say that no, he's guilty, now you can see that defender was innocent, but judge decision was that he is guilty. Now it is a type 1 error. In practically, you can say that in a scanner machine, in some or in a camera machine, where you have placed it on some road or some restaurant, and it will measure some ghost, nothing values. As a person, we say that it is a type 1 error. And then here the other error is that defender is guilty, then definitely he put it on the jail, like here. But you will leave it, for example, you will leave it, then we will say that it is a type 2 error. For example, in a reading, instead of 20%, the camera, he will read, instead of 20, he will read 30 values. That additional, here the more people are coming and they are giving some witnesses in the favor, and that's why he will be proved that innocence. Now these two types of error will be we will find out accordingly in the coming days. In statistical form, you can see that H is correct and H naught is wrong. H naught is correct or H is wrong. There are two options, like very similar that we have seen in a previous slide. Defender was innocent, defender is guilty. Now here H naught is correct and H naught is wrong. Now in experiment, instead of judge, we will have, if it is H naught is correct, then definitely we should not fail. We should fail to reject it because it is correct. And otherwise, if we reject it, then we will get some type 1 error. Because it is correct, then definitely we should fail to reject it because it is correct. Now again, instead of correct, you reject it, you will get type 1 error. And H1 is wrong, then definitely you reject it. Well done, you have rejected it here. But here, instead of rejecting, you fail to reject it in second form, you will occur type 2 error. Now, that how you will apply it, let's have a question here. First, you can see that we will get Z or T statistics, critical value, and accordingly we see that test statistics where it is for, either it is in rejection region or in the second region here. Okay, now it is actually test statistics formula that we will not go throughout all these. In the case of lower tail, that we representing mu minus Z over gamma standard deviation, sigma over n distribution. Very interesting result if you see this also, that if here n goes very, very large, that this value will become small. What will happen? That average of the sample will reach about the population. Now, on the basis of this story, the whole thing occur. That's why we'll say that if we have a more sample, then definitely the result will be more accurate. And again, for upper tail, we can say that we have to find out for the greater than value, is it is greater than or not, one-sided story, then we have the same formula, but here instead of negative, we will have a plus here, the value. It is actually distribution, statistical distribution we will follow. And for two-tail test, that we will have an example that is coming here, we apply this formula here, that is a mean of sample alpha by 2. Why we say alpha by 2? Because the half people will sit here in left side of the judge, and 2.5% people will sit here if total are 5% are innocent. Half of distributions. That's why it is coming on that side. Okay, let's have a question to better understanding, and we will solve it accordingly. Now, question is that test the claim that is a true diameter of the manufacturing bolt is 30. Now, remember that it is a 30 value is given here for 100 value. Now, average sample is 29.84. Now, we can say that here we consider that 100 is population and the mean value is 30. And we here consider that we get some sample and whose average is coming, mean is coming 29.84. and standard deviation of population is also given, and we have to check it out either in 0.05%, 5% accuracy, it is almost 30 or not. It is satisfied, means the relationship is strong as 95% or not. Now, according to procedure, we will write H naught U is 30, and then H1, that is the alternate hypothesis, that is not 30. Now you can see that 30 was actually the population value, and here we will have a sample values, but here we say that the average value is not 30, means that here we are getting some values from the sample who is not 30, because it is lesser than, you can see, or greater than. Now we want to check it out either that this value 29.84, it is coming in the confidence interval with 95% accuracy or not. Now it is your choice. We consider here that alpha is 0.05 and here the total n is 100. Now first step was that we have taken as a z distributions. Now z distribution is generally normally distributions, and if this standard deviation is given of the population, then we apply this z distribution here. Now critical value is 0.05, and the critical z for this value we get it 1.96. Now it is a value that it is a border line. It is a borderline which separate the null or alternate hypothesis. That on one side it will be null and other side it will be alternate hypothesis. For different value of alpha, you will have a different value of z. That is for 0.05 it is 1.96. Now from where you will get it, the table of hypothesis testing is available, but you have to check it out. Either you are going for alternate hypothesis or left tail, right tail accordingly, and then you have to get it out. And next we have to find out test statistics. Test statistics was this, that was actually judge who will decide either he is guilty or not. Now what it is depending upon, both average value, that is the sample, and population, just we will put it here, and then it was standard deviation, and total population was here 100. Now after substituting you will get minus 2, you can see, and what is here, it is a z value, that is a plus minus 1.96, it is minus 2. Now remember that z value from the table we have calculated from here 1.96. You will get some table in the books. Now this table you can see that for different value of alpha you will have a different value of z. Now it is understood, in the table it is written that, for example, if 5% are innocent, then your line will become here. If 10% are innocent, then or 0.01% are innocent, then means 1% are innocent, the line will come here, and if 20% are innocent, line will come here. Now these are the actually, you can say that non-relationship it will tell us, that alpha, critical value. Now here it is minus 1.96 that we have calculated from the table. Now it's the last slide, you can see that in test statistics we have seen that we have taken alpha by 2, because total 5% we have the value of alpha, then we what 0.25% will sit here and 0.25% will be sit here. How, you can say that. On the other hand, you can say that 2.5% or here 2.5%. How people will be here and how people will be on the other side. And the value of z that we have calculated from here, you can see that, yes, just hold on. Yes, value of z that we calculated from here, you can see that z is coming minus 2 here. Minus 2 is lesser than minus 1.96. What does it mean? Means minus 2 is inside the shed, inside the, you can say that where the rejection region is on the both sides. Why? Because the negative value is where the curve is coming to end. Now since it is on the this side, that the people are innocent, people are sitting, means that our test statistics is right. What we get it, we get that actually 95% people are giving the criminal relationship witnesses. That's why we reject the null hypothesis and we say that the claim is true. What was the claim? That the criminal has some relationship with the crime. Now, if you like this video, then kindly comment so that we can accordingly make more videos